Alright, so this is going to be a generally quick video. And we kind of touched on this a little bit today. This is going to be 3.5, and this is overlapping triangles. Alright, so with overlapping triangles, you really have only one objective, and that is to use overlapping triangles and proofs. So the hardest part about this is being able to see the triangles when they're there. So this one, like for example, we've got 1, 2, 3, 4, 5. Looks like 5 triangles off the top of my head. So if we were given that DB, so this whole segment here, is congruent to AC, which is that whole segment there, and that AD is congruent to BC, we need to prove that angle D is congruent to angle C. So what we need to do is we need to take a look at these different triangles and see what's going to help us prove that the best. And judging from this, we've got a long part here and this. So we've already got two sides for each of these bigger overlapping triangles. So let's run with that. So for statement 1, we have our given, okay, and our other given is statement 2. So for this one, I'm keeping them separate. All right, so now I can also say that AB is congruent to AB because of the reflexive property. All right, so now you'll notice I kind of color-coded the triangles here to make it a little bit easier for you. So now I have 3 sides from each triangle. So I can say that triangle ADB is congruent to triangle BCA as shown in steps 1, 2, and 3. And now I can say, and so that's side, side, side. Now I can say that angle D is congruent to angle C because of CPCTC. So remember, we've got our triangle postulate. And once we've done that, then we can go to CPCTC. Okay, so let's try another one. We are given angle 1 is complementary to angle 2. Angle 3 is complementary to angle 4. We need to prove that angle 1 is congruent to angle 3. Or we're also given angle 1 is congruent to angle 3. My apologies. And we need to prove that AB is congruent to CD. So let's go ahead and get started on that. We have our givens. We actually have, let's see, these are probably going to be the best 2 triangles to use before we even get into that. We've got ABC and DCB. So we're going to go ahead and start with those. We'll list our givens. All right. So we know that angle 1 is congruent to angle 3. We know that 1 is complementary to 2 and 3 is complementary to 4. How does that help us out? Well, we can say angle 2 is congruent to angle 4 because angles complementary to congruent angles are congruent. And then we can use that and go ahead next and say that BC is congruent to BC. So now look, if you look, I've got the beginnings of I've got an angle on the side, and then I've got this, which is very telling. Right, those bits there. So then I can say that triangle A or angle ABC and angle DCB are right angles because complementary angles form right angles. I can then say that angle ABC is congruent to angle DCB because right angles are congruent. So that would allow me to say that triangle ABC is congruent to triangle DCB because of angle side angle in steps 4, 5, and 7. And then lastly, I can say that segment AB is congruent to segment CD by CPCTC. Now this in here, you could have done this a little bit different. Now that you had proved that angle 2 is congruent to angle 4, you could have absolutely gone in, if you wanted to, and said that angle ABC is congruent to angle DCB because of addition different, or just addition property would have been fine. So if you did that, or if you wanted to do that, that's fine. Just be careful of that, okay? All right, and finally, things to remember when doing any proofs by Mr. Higgins. 1, take your time. 2, explain everything. And 3, with CPCTC, you must prove 2 triangles are congruent first. Yeah, I know I've said that a lot. I just want to make sure I kind of send that point home. But that is it. That's the video. You guys have a great evening. We will see you when I see you. Take care, guys. Oh, yeah. Don't make assumptions. Don't forget about that. All right? Now we're done.